Hello students, welcome to this lecture on scalar and vector of chapter number 4 of class 11 physics. In this chapter, we will introduce the topic scalars and vectors, multiplication of vectors, addition and subtraction of vectors, resolution of vectors and vector addition using analytical method. Knowledge of scalar and vectors is very important to study various physical quantities extensively used in physics. So I welcome you to this section. All the points are important and you have to remember it for solving all the problems of class 11 physics. I welcome you once again. Scalars and vectors. A quantity which has only magnitude is called scalar. For example, speed has only magnitude but no direction. Mass has only magnitude but no direction. Density also has only magnitude but no direction. Similar is the case with volume. Hence, every real number is a scalar quantity. Vector. A quantity that has magnitude as well as direction is called a vector. For example, displacement, velocity, acceleration, and force. A vector is represented by a straight line. Please see the figure here. This is a vector. This is a straight line with an arrowhead. Hence, a vector is represented with a straight line. This is a straight line with arrowhead. The length represents the magnitude and the arrowhead represents the direction. This is the direction. A vector is written as A. See here in the figure A, capital A with an arrowhead. The magnitude of vector is called modulus and written as mod A. That is two parallel lines in between vector A, capital A with an arrowhead is written. In some textbook, bold letters like capital A, small a, etc. Bold letters are used to represent the vectors and their magnitudes are written in the light face letters. That is light A, B, A, P, Q, R, etc. Unit vector. A unit vector whose magnitude is 1 is called a unit vector and its symbol is a hat. You see this is a different, this is not an arrow, a vertical arrow you can call. Vertical a, small this is a, this small a with a hat is defined as a unit vector and written as a is equal to unit vector a is equal to vector a divided by mod a, or a vector a with an arrow equals mod of a into a. Please remember this. Then what is its significance? Let us define null or zero vector. A vector of magnitude 0, that is it has no magnitude, its magnitude is 0, is called a zero or a null vector and it is denoted by vector 0. Why is it needed? Suppose a particle moves from position P to P dash and after some time again it comes back to P. It moves from P to P dash and moves back to P. Then the total displacement is 0. To indicate that the displacement, we use a null vector to indicate that the total displacement is 0. Position and displacement vectors. Please see the figure A where displacement is shown. P is a position. OP is a position vector. O be the origin. P and P dash be the positions after T and T dash seconds. Time T, not seconds, time T and T dash. OP is a position vector at time t. OP is a position vector at time t. OP dash is a position vector at time t dash. And its magnitude is, OP magnitude is vector r, and position vector OP dash is represented by r dash. Its magnitude is r dash. So PP dash, if you join the initial position P and P dash, we get PP dash, and it is called the displacement vector. P to P dash is displacement vector corresponding to motion from point P at time t to position point P dash at time t dash. It is important to note that displacement vector is a straight line. It is a straight line here as shown in the figure. But the path length can be different. P to Q, Q to R, R to S, and then again B to P dash. It can take different paths. But what is important here in displacement vector is the initial position and the final position. Hence, it is important to note that displacement vector is a straight line joining the initial and final position and does not depend on the actual path undertaken by the object between two positions. The magnitude of displacement is either less or equal to the path length. That means the displacement is always less than path length. Though path length may be greater than the displacement, but the magnitude of displacement is always less than path length. Equality of vectors. Please see the figure B. Here, two vectors A and B are shown. One vector A is OP and vector B is QS. So both are parallel to one another and their magnitudes are also equal. So these A and B are called equal vectors because they have the same direction parallel to each other. Hence they are equal vectors. If the direction of A is different from that of A as shown in figure C, it is unequal vectors. It is, you see, A is in this direction, B is in this direction. So they are different directions. If the directions are different, then they are called unequal vectors. Multiplication of vectors by real numbers. Please see the figure. In the figure, A is the given vector. We have to multiply vector A by a scalar number lambda. So multiplying vector A with a positive number lambda gives a vector whose magnitude is changed by a factor lambda, but the direction is the same as that of A. So here A is a vector and we have multiplied it by lambda. So the new vector is lambda into A, which has same direction as that of A, but its magnitude is increased by lambda. This is denoted by lambda A and defined as mod of lambda A equals mod of lambda into mod of vector A, where lambda is a scalar, that is real number greater than 0. Multiplying a vector with a negative number minus lambda. Please note, negative number minus lambda gives another vector whose direction is opposite to that of A. Please see the straight line, red colored straight line, whose direction is opposite to that of A. So the direction of the new vector in case of negative number is opposite to that of A, and it is denoted by minus lambda into A, and its magnitude is lambda mod A. The factor lambda by which A is multiplied could be a scalar having its physical dimensions. Then In such a case, the dimensions of lambda A is the product of dimensions of lambda and dimensions of vector A. For example, if we multiply a constant velocity vector by duration of time, we get a displacement vector. This is applied in physics. Next section, 4.4.1, addition and subtraction of vectors using graphical method. There are several methods of addition and subtraction of vectors. That is triangular method, parallelogram method, and analytical method. In this case, we will consider graphical method. Consider two vectors, vector A and vector B, as shown in the figure. We have to add first vector A to vector B. The general rule for addition and subtraction of vectors are head to tail method or triangular method. Please see the figure. The vector A has a head marked arrow direction. This is head, and tail without any arrow is tail. This is the tail end and this is the head. Similarly, for vector B, this is the tail end and this is the head where arrow mark is there. Addition of vectors. To find the sum of A plus B, we place vector B so that its tail is at the head of A. Please see the figure here. This is the given vector A and this is the tail end of B. So we place the tail of B such that the tail starts from the head of A. So this is head of A and tail of B. So this is head of B. Then we join the resultant from origin to the vector head of B. This line R1 represents the sum of A plus B. This is R1 is equal to vector R1 is equal to vector A plus vector B. For subtraction of vector, we reverse the vector B. That is, to find the A minus B, we place A as it is and reverse the direction of B. This is shown here in this diagram. This is B and the top one is minus B. So, tail of minus B is placed at the head of A and the head is joined from the origin. So, R2, vector R2 is equal to vector A minus B. Therefore, we define the difference of vector A and B, vector B as sum of two vectors A and minus B. Therefore, A minus B is equal to A plus of minus B. Properties of a vector addition. Commutative property, that is A plus B is equal to B plus A. That is, the A can be written first or B can be written first. That is the commutative property. Distributive property. If you multiply n into A plus B, then NEA, it becomes, the result is n into vector A plus n into vector B. Associative property. So, let us consider three vectors A, B and C. A plus within brackets B plus C is equal to within brackets A plus B within brackets plus C. That is, the brackets can be interchanged. That is the associative property of vectors. Triangle law of addition. Vector R is equal to A plus B as we have seen. See, here is a 0 origin. Here is a vector A, OP is a vector A, OQ is a vector B. So, we want to add it by a triangular method. That is, we draw a line parallel to Q, that is the dotted line here, and join and SP parallel to vector P. If you draw like this, the resultant OR is equal to OS, sorry, the resultant resultant R is the equal to vector A plus B. Parallelogram law of vector. It states that if two vectors are acting simultaneously at a point represented by two adjacent sides of a parallelogram. See here, two vectors, vectors A and vectors B are acting on the two adjacent sides of a parallelogram. Then the resultant here is A square plus square root of A square plus B square 2AB cos theta. That is using Pythagoras theorem. So we can define vector resultant R as A square plus B square plus 2AB cos theta. These are the basic things of a geometry. Polygon law of a vector addition. If a number of vectors are represented by the sides of an open polygon taken in the same order, then the result is represented by closing the sides of polygon taken in the opposite order. Resolution of vectors. Vectors can be resolved. A vector A can be resolved by using resolution of vectors method. See here, vector A and the angle between the x-axis, we can draw a vector from origin. This is the x-axis and this is the y-axis. So we have to resolve the components of vector A along x-axis and y-axis. See, the process of splitting a vector into two or more vectors is known as a resolution. As shown in the figure, A makes an angle theta with x-axis. Then vector A is equals AX into I. I is a unit vector along x-axis. It is a unit vector. Multiply with unit vector plus AY into J. J is the unit vector along the y-axis. This is the J and this is I. That can also be written as AX square plus AY square equals A square. That is cos squared theta plus sin squared theta. Because AX is equal to A cos theta and AY is equal to A sin theta from the knowledge of our trigonometry. Therefore, A is equal to square root of AX square plus AY square, and tan theta is opposite side by adjacent side, that is AY. So with respect to this theta, opposite side is AY and adjacent side is AX. This is the relation. In the previous section, we studied about the components of a vector in a plane. In this section, we will study about the rectangular components of a vector in space. Please see the figure shown. Here there are three axes: x-axis, y-axis and z-axis. This is the x-axis. Perpendicular to x-axis is y-axis and perpendicular to both x and y-axis is a z-axis. And the unit vector in the direction of x-axis is I and unit vector in the direction of y is a j. And similarly, a unit vector along the z-axis is k. All these unit vectors I, j and k are mutually perpendicular to one another. That is, the angle between I and J is 90 degrees. I and K is also 90 degrees. Similarly, the case with J, which is perpendicular to both I and K. Now, consider a vector A. Consider A as shown in the figure on the right hand side. This is the vector A which is having an angle which is inclined at an angle alpha to the x-axis, and its angle is beta with respect to y-axis, and the angle with respect to z-axis is gamma. So A has got, the vector A has three components: AX along x-axis, AY along the y-axis, and AZ along the z-axis. So this is written here as shown on the screen. Vector A is equal to AXI plus AYJ plus AZK, where AX is the coefficient of unit vector I, AY is the coefficient of vector J along y-axis, and AZ is the coefficient of unit vector K along the z-axis. And now we will define AX in terms of angles, their angles with respect to their axis. So AX will be equal to A into cos alpha, and AY is equal to A into cos beta, and AZ is equal to A into cos gamma. This is as per our basic knowledge of trigonometry. And magnitude of A, vector A is calculated as square root of ax square plus ay square plus az square, and cos alpha is given by adjacent side by hypotenuse. That is, cos alpha is equal to ax divided by a, and cos beta is equal to ay divided by a, and cos gamma is equal to az by a, wherein we had described alpha, beta, gamma as angles between the vector A and its respective components along x, y, and z axis. Similarly, Ax, Ay, and Az are magnitude of vectors A in the directions of x, y, and z. Thus, we have resolved the components of vector A along the three axes in the space. And these angles are also given by cos squared alpha plus cos squared beta plus cos squared gamma is equal to 1. Therefore, cos alpha, cos beta, and cos gamma are called the direction cosines of A, vector A. Now let us study about vector addition using analytical method. In the previous sections, we studied about vector addition and subtraction using graphical method or triangular method or parallelogram method. In this method, it is a very simple method using analytical method. It is easier to add vectors by combining their respective components. In the previous section, we have studied about three components of a vector along x, y, and z axis. So it is easier to add vectors by combining their respective components. Consider two vectors A and B. Let us define vector A as A is equal to AXI plus AYJ plus AZK, where AX, AY, and AZ are the coefficient of unit vectors I, J, and K along three axes x, y, and z. Consider another vector B having a coefficient B defined as B is equal to BXI plus BYJ plus BZK, where Bx is a coefficient of I and a magnitude of vector b along x-axis, by is the magnitude of vector b along y-axis, and bz is the magnitude of vector b along the z-axis. So we have to add a and b. Adding we get a plus b is equal to ax plus bx into I plus ay plus by into j plus az plus bz into k. Let the resultant vector be represented by letter r. R vector r is equal to rxi plus ryj plus rzk. Let it be equation 2. So we define Rx as Rx is the coefficient of vector I, unit vector I, that is Ax plus Bx, and Ry is the coefficient of unit vector J, that is Ay plus By, and Rz is the coefficient of vector K, that is Az plus Bz. Thus, each component of R is the sum of the corresponding components of A and B. In this way, this method can be extended for the addition and subtraction of any number of vectors. That is, we have just seen only two vectors in this example. We can apply this to any number of vectors. Let us solve a numerical problem to find the resultant of two vectors. Question number 1. Rain is falling vertically with a speed of 35 meters per second. Wind starts blowing after some time with a speed of 12 meters per second in east to west direction. In which direction should a boy waiting at bus stop hold his camera? So there are two vectors, that is a vector due to rain which is downwards falling vertically with a speed of 35 meters per second. The second vector is a wind due to wind which blows from east to west direction, and it is blowing with a speed of 12 meters per second. A boy is standing at the bus stop and he is holding the umbrella, and we have to find the direction of umbrella. Let us solve it. In all such problems, the first step is you have to mark the directions as shown in the figure: north, south, east, west. So next step is to mark the two given vectors. So the two given vectors are VW due to wind, which is shown from in the direction east to west, and the second vector is VR due to rain, which is falling downwards. So VR is downwards and VW is east to west. The resultant, let it be R, which with an angle which is at an angle theta to VR, vector VR, as shown in the figure. So the resultant is given by R is equal to square root of VW square plus VR square. This is the R is the hypotenuse, VW is the opposite side, and VR is the adjacent side. So therefore R is equal to square root of VW square plus VR square, and substituting the given values we get R is equal to square root of 12 square plus 35 meter square, 35 square, and its unit is meters per second. So simplify, we get the result as 37 meters per second. To find the angle theta, we have to take the tangent of the angle, that is the ratio, trigonometric ratio tan theta is equal to VW by VR. That is equal to VW is 12 and VR is 35. 12 by 35, and the ratio, simply after simplifying we get it as 0.343. To find angle theta, we have to take inverse of the tangent angle. So therefore theta is equal to tan inverse of 0.343. So From tables, we get this value tan inverse of 0.343 as 19 degrees. So therefore, the boy should hold his umbrella in the vertical plane at an angle of about 19 degrees with vertical towards the east. Next question. The next question, we will find the resultant of two vectors A and B in terms of their magnitudes and angle theta. This is a standard derivation. Maybe you will get a question of about 5 marks. Let us find it. So, question number 2, I will read it once again. Find the magnitude and direction of the resultant of two vectors A and B in terms of their magnitudes and angle theta between them. Please see the figure shown on the screen. Here, OP is the given vector A, OQ is the given vector B. So we have to add the resultant of we have to find the resultant of this vector A and vector B. These are placed as shown in the figure and complete the parallelogram OQSPO by drawing QS parallel to OP and PS parallel to OQ. Similarly, by joining the edge O and S, we get the resultant. That is, OS is the resultant of vector R. So, draw two perpendiculars, perpendicular PM perpendicular to OS and SN perpendicular to extended part of vector A. That is, extended part of OP is PN as shown in the diagram. Angles are also the angle between a vector A and vector B is theta, and the angle between vector A and the resultant is alpha. Similarly, the angle between the vector B and resultant is beta. So let us solve this problem. So resultant of vector R, we have to find out. Let it be R is equal to A plus B, vector A plus vector B. So draw PM perpendicular to OS and SN perpendicular to PN. In the right angle triangle OSN, that is OSN, we get using Pythagoras theorem, OS square is equal to SN square plus ON square. But ON is equal to OP plus PN from the figure. So that is OP is vector A plus B cos theta. PN is B cos theta. Therefore, R square is equal to, from this relationship, R square is equal to SN square. SN is B sin theta square plus A plus B cos theta whole square. Therefore, R is equal to, taking square root, R is equal to square root of A square plus B square plus 2AB cos theta. You please expand the previous relations using the formula A plus B whole square is equal to A square plus B square plus 2AB cos theta, and simplifying we get R is equal to square root of A square plus B square plus 2AB cos theta. Let it be equation. This equation is called law of cosine. Please remember, this is called law of cosines. Next, we have to find the relationship between angles. So from the figure, SN is equal to B sin theta. So this is angle theta. In this triangle PSN, SN is equal to B sin theta, that is opposite side. That is also equal to, considering the triangle OSN, that is also equal to r sine alpha. Alpha is the angle between the resultant and A, and it is here in this triangle OSN. We get Sn is equal to r sine alpha. Simplifying, we get r by sine theta is equal to b by sine alpha. Similarly, in triangle, in the right angle triangle, PMS, we get PM is equal to A sine alpha, that is equal to B sine beta. Let it be equation 3. Simplifying, we get A by sine beta equals B by sine alpha, which itself is equal to R by sine theta. This relationship is called equation of law of cosine. You remember, this equation is called law of sines. This equation is called law of sines. With this, we have concluded the vector algebra portion of chapter number 4, wherein we have studied about the vectors, scalar multiplier, vector addition, vector subtraction, rectangular components, and we have also solved some worked example. In the next lecture, we will take up motion in a plane with constant acceleration and relative velocity in 2 dimensions. Till then, goodbye.